So the first thing we're going to look at is this general expression right here. So that's is that a series or a sequence? It's a series. Why? Summation, yeah. So this is the general form right here. This is the general form. Take a look. What it says, you know what this means. Cn is any formula with n in it. Any formula, just n. No x's, just n. So there's no x's right here. So this could be like 1 over n. It could be n factorial over n plus 1 factorial times 2 or something like that. This is just something with n. And this is x minus some constant a raised to the n power. This is a very specific type of series. Anybody know what it's called? Anybody know what it's called? We're supposed to read it, I think you're supposed to read it. Power series, exactly. So it seems a little arbitrary that we're looking at this like one. It seems pretty specific, right? It's like, why do we look at this like one specific type? They will be very useful later. So we're setting you up with the mechanics to use power series to do some pretty powerful things. So what we're going to do is let's just take a look at this one right here. This is a power series. Why is this a power series? Because I'm going to break this apart into 1 over 2 to the n, x minus 0 to the n. This and this are the same. Do you agree? You agree it's the same? So does that fit the formula that's right here? It does fit it. It's something with n times x. It's said to be centered around 0. So what you notice, or what you might notice, is depending on the value of x, the series might converge or diverge. Depending on the value of x, it might converge or diverge. So for example, on this one, what happens when x is -1? You end up with, you write the formula, n equals 0 to infinity of -1 to the what? Over 2 to the n, right? What type of sequence is that?
Alternating.
Alternating. What's it going to look like? When n is 0, what does that equal? 1. And then it's minus what? 1/2, and then it's adding what? 1/4, and then it's subtracting what? 1/8, and it's adding what? 1/16. So, do you know if that converges or not? What type of series is it?
Alternating.
Oh, well, give me more. It's an alternating metric. Ah, there it is. I gotta like dribble it out here. What's the ratio? -1/2, right? And you know that the absolute value of that is less than 1, so therefore what? Converges. Are you with me so far? So it does converge. Okay, so for that x value, it converge. Let's try it for this one. You have the summation here, n equals 0 to infinity of 3 to the n over 2 to the n. Well, off the top of your head, do you think that converges or not?
Diverge.
Why?
Ratio.
Yeah, what's the ratio? 3/2. It blows up, right? The terms keep, because the ratio is greater than 1, the terms keep on getting bigger, so therefore what happens? It blows up. Please don't pack up before the bell rings or nasty things start happening to the entire class. Oh, you have to do that. Oh, I see. This is those people fleeing to college land, is it? Oh, okay. Okay, I got it. Got it. So, depending on the value of x, hold on a sec, and what we're going to work towards finding. We know that this power series right here, this one, it converges for those specific two values. What might it be more useful to know? Do you know a lot about geometric series? You know a bunch. You can analyze them pretty quickly. But sometimes, it's kind of like when you get 2 points, you have to write a line, the equation for the line. In this case, you have to write the equation for the series. Write me the equation for that series. Find an expression, not an equation because there's no equal sign, but find an expression for the general term of that series. Yes, Cameron.
So sum
Yep.
from n equals 1 to infinity.
Okay.
So parentheses.
Yep.
X minus parentheses n plus 1 and parentheses and that one to the 2 to the n plus 1.
Wait, hold on. So I think it just should be x minus 2 to the what power?
To the n. That's not what I was saying. To the n plus 1.
To the n plus 1 power?
It's 2.
No,
It's 2 times n plus 1, right?
to the n, 2 times n plus
Like that?
Right.
Because the first power is 4, right?
Right.
1. Yeah.
And the second power is 6.
And 2, 2.
Oh.
Sorry.
That's
Is it 2 times n or is it 2 times n plus 1?
2n plus 2. 2 plus 3, 2 times n plus
2 times n plus 1? The number goes 4, then 6, then 8, right? So that's 2, 3, 4. So that's 2 times what?
1. n plus 1.
N plus 1. Yep. Okay. So the first one you plug in 1 and you get 2 times 2 is 4. Plug in 2, you get 2 times 3 is 6. And then what's it over, Cameron?
N plus 1 squared.
Is it n plus 1 squared? Nice. Do people agree with that? So here's the thing. Sometimes you will not be given the nice general form like this. You'll just build it, and then you're going to have a lot of analyses that you can run. You actually know the analyses that you can run. So if I asked you, does this converge? For example, we're not going to start with something that's complex, but if I asked you, does this converge? It would converge and diverge for different values of x. Which of the convergence tests do you think we're going to try to use to generate a radius of convergence? Oh, yeah, so you see this, maybe break it apart and then use like the integral test? No, we're not going to use the integral test. We're not going to use the integral test. Anybody else? What's another test we can run? What's another test you know of? If I plug in 1, for example, what happens if I plug in 1? So all of them become 0. So therefore, does it converge?
Yes.
Yes.
No.
Yes. 0 plus 0 plus 0 plus 0 converges to something. It's called 0. Okay. What happens if I plug in 2 into this? What happens if I plug in 2? It's like x equals 0. This thing is 0. But what about x equals 2? You end up with 1 minus what? A half plus a third minus. Oh, we've seen that before. What is that? That's the alternating harmonic. And what do we know about that?
Diverge.
Really? Really? It's a convergent series that goes to 0. And all the terms, the absolute value of all the terms are getting smaller. We've talked about this before. What does it do? The alternating, what does it do? It converges. You remember this was the example of the thing that doesn't work backwards? Does the harmonic series converge? No, but does the alternating harmonic? Yes, it does. Yes, it does. Yes, it does. So there's a lot of dense terminology in this that we're not going to get into quite yet. Your homework tonight, we stop